So, while you're all here and you're fresh and I haven't either bored you to death or made your brains explode, I have to do my obligatory selfie with you. Now, you've all spread out, so I'm going to go over there. I'm not going to fall off the stage. I have nearly done that before. And you all have to wave. This is also, if any of you give me a red out there, I can hunt you down, okay? Because I have everyone's faces in here, okay? So, nice big smiles and waves. I compare every audience, so you want to be the best audience, don't you? All right. So, big smiles, big waves. 3, 2, 1. Yay! Thank you very much for indulging me that. I'll still hunt you down. Alrighty, so my name's Layla, and you are here for Distribu-ready with the Modular Monolith. Yay! Thank you for coming here. There are a lot of other awesome talks this morning at this time slot, so I'm very pleased to see all your lovely faces here with me. So, I feel like I need to give you a content warning because I had a lot of fun with AI-generated imagery, like so many of us have, and I've got some very weird things in this slide deck, but I enjoyed it, and I hope you do too. But yes, they are weird. These aren't real things, some of these. I've omitted some of them because they're just like a little disturbing. I tell you, AI-generated imagery gets very, very strange. All right, so I want to start with this quote by Sir Richard Branson. And I think it's something to really bear in mind as you go through your software development and your architecture, that complexity is your enemy. It is so easy for us to make things more complex. Add in yet another bit of tooling, another library, and just keep adding to the overhead of your applications, and just because it seems like the simple thing. Maybe someone's already made a library that does this, but maybe it's not maintained, or there's some other issues, or it doesn't quite work, or that you just have to learn how to use it. But everything that you add into your application is adding to its complexity, and it's so easy to do. So I want you to keep this in mind as we talk about everything that we're going to talk about today. And it is really hard to keep things simple. And if you were in the keynote yesterday, it's about thinking critically about, do you actually need that? Does it actually solve the problem? And if you missed the keynote yesterday, definitely watch it on catch up, because there were so many things that apply to software. So that's the other Layla who gave the keynote, and this is this. So you just have to remember to go watch Layla's, or Layla, as a colleague or friend likes to call us. So just bear this in mind as you go through this talk, or any talk, okay? So we are going to talk about a modular monolith, but that does mean that we are going to be thinking about distributed systems. And the typical demonstration or imagery for monoliths, and that is rocks. So we have this here with Stonehenge in the background, and you can think of that as a distributed system with lots of rocks. I think those sarsen stones are actually coupled by the linking stones on the top, but we won't go into that. We won't go into that today. That's a different talk. But we have our monolith. So we're going to be thinking about the differences between these and how you can relate them as well. So what is a monolith? I'm sure most of you started your development careers working on monoliths. It's a single application, all in the same repository, and it's a single executable. Now, this comes with a lot of benefits. You don't have to learn how to talk between these. You don't have to secure between your different bits and pieces within it. You have a single thing to deploy. There are so many benefits to the monolith. But it is difficult when you want to scale, and it can be difficult to maintain because everything is all in the one repository, and we start to blur those lines between different parts of the application. So what is microservices architecture? Well, this is like the polar opposite. You're starting to divide everything into lots of different executables. So you can just go and work on one single repository, and then you can deploy that independently of everything else. That's a key point, that it's independent of everything else. But it does have a load of drawbacks. Complexity is through the roof. You have to deploy multiple things now. It's difficult to run locally on your system. You probably have to start up all manner of containers and services, and it gets really complicated. But you do have that issue that it's really easy to scale. You can swap modules in and out. So you've got that easier sort of life cycle management, feature-y thing going on with it, okay? So a lot of people want to move towards microservices. So when you are thinking about what you need, we generally think of these two options. We have, I want to scale and meet demand, so we could go through our current monolith and we could scale it vertically or horizontally, make multiple different instances of it or give it more compute. We can go through the code, we can try and optimize it, find where the bottlenecks are, where all those bits are sort of, just not working as smoothly as possible. Or we can go and break apps into individual services that can all scale independently. Now, sometimes it won't be the best reason that you go towards distributed systems. It'll be because you want it on your resume. Don't do resume-driven development. Definitely don't do that. Don't do CTO-driven development. So you'll get CTOs like, I'm on the golf course and talking to this other CTO or CEO or C-suite somebody, engineering manager, and like, I've got microservices. And they're like, yeah, we're getting microservices. Okay, engineering team, we need microservices now. I've just told this big wig over here that we've got them. So try not to do that type of development as well. It's not a good reason because, again, complexity. Complexity is the enemy. Okay, so if we compare the two architectures, this kind of makes them look like black and white. We have the ease of development with the monolith. I've already said that microservices are difficult. We'll talk later about how that might be getting easier. Updating and maintaining, everything's easier in a microservice, isn't it? Because it's all encapsulated. You're not having to tease through all your code. The monolith is restrictive. You can't scale it. And this paints a picture that microservices is the way forward. Because it does sound pretty straightforward, doesn't it? Just divvy it all up, all these executables, and away you go. But it does come at a cost. Simplicity. Can you see the theme coming through here, okay? We want to keep things as simple as possible. And microservices are just complex. I know a lot of companies have gone to microservices architecture and they're reeling it back in. They're recomposing, I guess would be the word. They're bringing all those services back into a single executable or a few executables. And that's not easy to do, just to backtrack on that. So let's have a talk about the journey to distribution. You don't just suddenly get a distributed app. We have this journey. Now, I use this chart a lot. I stole it, so I may as well use it a lot. I stole it from a colleague, who stole it from another colleague, who stole it from someone who owned it. Who knows? I don't care. It's mine. And this is what you think you're going to do. You're going to take your monolithic application and it's going to become microservices. Yeah? Oh, okay. This is where you're going to end up. You are going to end up at the distributed monolith. That's a very bad place. It's a really awful place to be because now you haven't got a distributed system and you don't have a monolith. We really don't want to be there. Now, I will say you might go there on your way to places because you've got to break a few eggs to make an omelette, haven't you? I've been using that statement a lot recently. Someone give me a different one that says the same thing. You can find me afterwards. But This is where you're going to end up if you go without proper planning and thinking, okay? So, I told you it got weird, I warned you, okay? The dangers of the distributed monolith. Creepy, weird cotton monsters come out of your keyboard, jump up behind your desk, and savage you, okay? I thought it was quite cute. I liked it. So to understand where the danger comes from, you kind of need to know what it is. And people say, oh, okay, what is it? Is it like multiple monoliths spread around? Let's take this common scenario, okay? Because this is something people always ask me when I talk about distributed systems is, yeah, but they're both using basically the same data. Do I have to duplicate my databases? Can they not just both share the same database? So let's say, okay, yes, let them share the database. So we've got these two services both working on this database. Now, one service needs to update that database. They're going to do a migration, whatever needs to be done to it to make it work. What about this one? Now, we have to go and do that migration to the other service. That doesn't seem like it's in the spirit of distributed systems. That's not where we want to be. Now, we've coupled our applications. Our applications have a friend, a tag-along that they have to go and deploy everywhere with, okay? We cannot deploy our individual services without having to go and update and deploy the other coupled services, okay? That's what a distributed monolith is. We've got all those connections, and now we have to deploy them all. We haven't got those benefits of rapid development cycles and rapid releases and everything encapsulated that we wanted with microservices, okay? So this is really hard. We don't want this. AI generated, it's creepy, isn't it? How good it is. So we have all of that complexity that we've been trying to avoid of our distributed system. We've got to think about all these supporting services, the deployment, all of those horrible things, the pain of debugging and writing code in it. But we have none of those benefits of independent, discrete services, all right? Because everything's coupled, it's got friends. And we don't have that lovely debugging experience where you can just put a breakpoint and follow the code path through as you're going with your monolith, okay? So you can see why we don't want to be there. Now, the golden rule, this sort of comes from DDD, domain-driven design. I know just enough of DDD to be dangerous. I have a colleague who is like world-class DDD expert, and he's always like, oh yes, you must do this, you must do that. And I'm like, yeah, I don't want to do that. No, that doesn't make sense to me. And he rolls his eyes at me. So I know just enough, and I think this is one of the rules that I think you should always try to keep in mind. And it applies across so many different aspects of software. So loose coupling and high cohesion. This is important, remember it. So what is the more pleasant journey towards our distributed systems? Well, remember this diagram. We now have the modular monolith on there, okay? So we've got this other option. So instead of going straight to microservices and ending up in a distributed monolith, we're going to move towards the modular monolith, okay? So this is a much nicer journey because this has a natural path to being easier to distribute. We're going to learn how that happens and how you get there, okay? So this is the way that I recommend you start moving. All right, and I always think of this little diagram, you know, you see memes of this everywhere. You do not want to be the miserable dude on the left there with the distributed monolith. Okay, we want the modular monolith. I'm a big fan of it, can you tell? So now back to this chart, we have this option. We have the modular monolith, best of both worlds, yay! Now, it has a lot of the problems, okay? So it's not all sunshine and roses. It does come with a lot of problems. We're going to be bringing that old friend in, complexity. So what is a modular monolith? So this is a single executable, but we've got a whole load of modules. We've encapsulated everything into individual modules. We can change them out. We can just work on those in isolation. We've got that sort of modular thinking that you have in distributed systems, but we haven't got that difficulty of lots of individual executables that we need to deploy. Everything is in a single runtime. So I want to introduce you to the KitKat pattern, okay? This is something I want you to adopt. You will adopt subliminal messages, because I think this really describes what we're trying to achieve with our modular monolith. So you all know a KitKat, don't you? Yeah? Okay, all right. Are there any like monsters in here that just take a KitKat and take a big bite out the corner? Oh, you monsters. Absolute monsters. I mean, ignore those few, very few, thank goodness, monsters. The right way to eat a KitKat, the right way, and I will die on this hill, is to snap a finger off, nibble all the chocolate off around it, and then eat the biscuit, okay? That's the way. So if you're not a monster and you snap a finger off, you can think of each finger as a module. It's one whole complete thing, but if you separate a biscuit, it's still the same thing. It's all there, but now we've got these two bits, okay? So that means it's an entire KitKat bar, the monolith. You know, each finger represents a module, and a finger can be broken off. So you could swap that finger out, you can do whatever you want with that finger. It's completely encapsulated. You could give it to a friend and they've kind of got their own KitKat bar, okay? But how does all this work in my application? Because it's very easy for me to say, yes, here it is. Let's say this is your plain old monolith. I've got n-tier architecture here. I mean, I don't really care what you have. It could be n-tier, onion, carrot. I'm sure there's going to be a carrot type architecture one of these days. There's all these names coming up. So I don't care. You can apply this to whatever architecture you are using. All right, you can think about it however you want. I'm not going to tell you what architecture to use. Just start thinking about how you could apply these principles to whatever you're doing. I will use n-tier as an example because I think most people will be familiar with that style of architecture. So if you think about your multiple tiers here, we're going to divide them up into our modules. And in those modules, they probably have the API, the business logic, all of their data access. Excuse me. Now, you may think this is, well, vertical slice architecture. They're not the same. If you want to learn about vertical slice architecture, my good friend Chris, who's sat over there, I see you, is giving a talk at 10:20 tomorrow on vertical slice architecture. Go to that. Learn about that approach. That is all about encapsulating features. It's not specific to monoliths or distributed systems. You can apply it in both. And it's a similar in the same vein, but still a different approach, okay? So I suggest you go and watch his tomorrow. So how do we decompose this application? Like actually start with it. Remember the golden rule. We have that loose coupling and high cohesion. We need to think about that. So we need to start looking for the areas of high cohesion. So high cohesion means that we've got areas that are closely related to each other. They're all doing stuff around the same thing. Okay, so if you have, I don't know, a notifications feature in your application, everything that relates to sending emails or text messages, everything to do with notifications is highly cohesive. So you start bringing all those bits together. And then you separate all of those highly cohesive things, those nuclei of sort of topics, and then you make sure that they're only loosely coupled to everything else. If you've got notifications over here and something over here, you don't want notifications to depend on something over here. We need that separation. So there's this chart. I think this is a bit pompous, especially number 4. It means higher quality code. I mean, it can do, but it does seem a little bit pompous. So you can see what that says. I'm not going to go through it. It's just about bearing that in mind and looking for those areas that you have high coupling and trying to tease those out so you can start getting these nuclei of topics or modules as they will become. So let's have a practical think about this. We want to incrementally do this in the largest chunks possible. So the largest chunk of cohesion, because we can start to further decompose. So we take that, everything to do with orders is one module. Everything to do with inventory is another module, and so on. So we've got all of this highly cohesive areas, and they're sort of loosely coupled. Now, you can further subdivide those modules or those areas of cohesion as you go along, and then you've got all the different things that make up your ordering section. Now, these can be modules in their own right. You could have them encapsulated in another one, so they're sort of everything else thinks it's one module. There's different ways that you can approach it, and that's your own decision on with your team on what suits you. But you can start to take these large areas and decompose them further. Now, that pesky database, remember the shared database and things. So we want to think about how we can decompose the database. And you will need to, all right? We'll get to when. There's 2 approaches, and as developers, you are going to be tempted to go code first. We always want to get into the code. Well, I do. I hate touching the database. I'm scared to death of databases. That was drummed into me as a junior developer. Make sure you run all your SQL queries before, test them before you actually run them. And I've been in a situation where the live database has been dropped in its entirety, not by me, by the head of my team. And Nathaniel, you might remember that. It was horrific. And there was a lot of blame coming my way. And I was like, no, it wasn't me. Someone did it on Boxing Day. And it was 10 days later, and Azure only kept backups for a week. Another story for another time. It was not good. So, okay, we have code first. So you go and look at your code base and you think, all right, this is where we're going to start pulling this section out, this module, we're going to pull that out. Easy, yeah? Database first, that sounds a little bit more complicated. But let's think about this. You've got your code first, you've pulled all your module out, everything's great, you've spent, I don't know, how many weeks doing your code, and then you come to your database. What happens if that data can't be teased apart in the way you want it to be? Because data is really difficult to decompose and separate. So then you'll have to backtrack and remove put your module back in and rethink this based on the data. So this is where the data first approach can be easier in the long run, because you divide your data, you're like, okay, I can see that the data is going to work like this, and then write your code accordingly. So how would you choose one over the other? Well, if you are pretty sure that your data is straightforward, that it will follow along, go with your code first, all right? If you think the database is going to be difficult and pesky, start there, make your life easier, because if you can't separate the data, you can go back to the drawing board and you haven't wasted any time with code. So that's what I just said. If you have that and you can't go, so we'll skip over that. And you may be asking again, we're not in a distributed system, do we actually need to decompose the database? Maybe not. You need to think about, are you actually going to go distributed anytime soon? If not, well, maybe you don't need to decompose the database. Your two modules can use the same data store. If you think you are going to distribute this system soonish, maybe you want to do this sooner. Or if you think it's going to be a problem, you want to do it. I really want to drum in that you should be pragmatic, not dogmatic. And this is so important. I've worked for team leads who have been so dogmatic that it's a horrible place to work. The example I can give you is I was learning to do TDD, and I was kind of writing some of my codes first, some of them after I've written my code, because I was learning and I was struggling with getting that test first mentality. He came over to me at the end of the day and said, I know that you didn't write your tests first. Okay, yeah, I'm pretty open about that. Next time you do that, I'm deleting all your code. Okay, that is being dogmatic. Do you know how that made me feel? Table flip. Okay, it's so unnecessary to be so dogmatic about things. Be pragmatic. Think, do I need to do this now? All right? Is it more complexity to bring this in? Or is it going to make life easier? Make the decision based on each individual situation. You will accrue technical debt. If you don't do it straight away, you will have that technical debt. You know you will have to do that down the line if you decide to distribute your system. But knowing that you have that technical debt is half the battle. What you do with that, another case, okay? So, how is this Distribu-ready? That's the title of the talk. How do we actually start breaking up this system and making it a distributable system? Now, remember this last section when we were talking about the Kit Kat pattern. A finger can be broken off and is in itself a self-contained chocolate bar, just like a module in your application. So we want to write our modules in such a way that I can take an entire module, make it an executable, deploy it, and nothing changes. That's the idea behind it. And then that's why when you structure and architect your distributed monolith, your modular monolith correctly and with thought, you are ready to go distributed. Now, DHH came up with the Citadel pattern. I don't like that. I don't think that's a good name. It doesn't evoke what I'm trying to do. So, introducing the satellite pattern. I'm giving you all my latest patterns today. So, if you think of a central, doesn't always have to be a modular monolith, with self-contained modules that can be broken off. Now, if you've got your monolith, you can go and tease something out and make it a module and then break it off, and they become satellites, all right? So this is starting to come partially distributed, incrementally distributed. So we carve off that satellite, and now we've got our modular monolith. You can have a regular monolith, and now we've got the satellite application. And that could be anything, all right? They can be standalone apps, they can be containerized, they could be a serverless function. And once you've got those, you can start to control them independently. So you can scale them to 0, you can just have them work as you need. So you need to be thinking, well, yeah, this notifications, we want to have like a gajillion emails sent out at the end of the month. So you scale up that notification service, you pluck that out and start to have that as a satellite project. Okay, So this leads us to an important question, the how. As we've sort of spoken about nebulous theory and things like that, but as .NET developers, I'm going to assume most of you are, how do we go about doing that? So we need to ensure that modules remain completely independent so that we can just break them off. How do we do that? How are all these modules going to communicate? Are we just going to have some kind of interface or service? How do they communicate now that we're trying to encapsulate them? And how do we enforce the architecture? We've come up with this whole new architecture. We need to keep it, and that takes discipline. Now, I have my little project that I've been working on for several years, and if you were in my workshop earlier in the week, we kind of built out Taki-Takos. So I'm going to explain how you can do it in your .NET applications using Taki-Takos as an example. So this is our modular architecture, and we have the client, whatever that may be, and then we have a web API. That is our single executable. That's the only executable apart from the client. We're ignoring that. That's something else. That's off on a CDN, whatever. But we have our web API as an executable. And then all of our logic is encapsulated into modules. So the API is going to extend all of the endpoints that you need within each module. And they all need to be self-contained to be able to pluck them off into satellites, okay? So you think you can't have all these endpoints in your web API like you might normally do and have inject a service, say an order service into your web API and call that. You can't do that because that's now coupling your application. So we have to think about how we encapsulate everything to do with your orders into the order module, but then call it within your executable, okay? And we need to be strict. We need to have rules laid out, and I know we don't always like rules, but with this you need rules, you need to follow structure. So how do we do that with .NET? With projects. That's the only real way we have for creating modules in .NET architecture. So each one of these things, I don't know if this, yes it does. So we've got orders, order tests, order contracts. I don't know why I'm holding my arm weirdly. But each one of these things is an individual module. And that's a class library if you're adding it to your .NET project. So we have all of those projects. Yes, you have a lot of projects, but it will make sense, okay? And then the web API is the only project that can reference the actual main module. So if we look at this, we've got orders and payments, menu, kitchen, notifications. They're the main module. And then the tests is supporting the module. And then the contracts is how things talk to the module, okay? So our web API is the only thing that can actually reference those individual modules because it's our executable. It has to be able to access those. However, the module project references cannot be other modules. They can only reference the contracts. That's the only way that we're allowing them to communicate. That's their API, the interface between them. So that leads us to how are these all going to communicate? Well, external communication, that can still come through more or less as you would on a regular application. So the web client is going to talk to the web API via REST, and that's going to come through, and then the web API will route that request through to the relevant endpoints in the module, and that logic will run from there. And we can keep doing that for all the different ones. We can do that for the post. It can come through, and it does all of those requests for it. That single executable is routing everything through to the relevant module, okay? Nothing's sort of going across. So that seems pretty standard. Now, in our modules, we can start to write our endpoints. Now, these are minimal APIs. I think that they lend themselves really well to this because they're really easy to write in such a manner. And there are quite a few libraries. Remember complexity when you start bringing in libraries, but it may be something you wish to do. I believe there's fast endpoints. Jeff Fritz has a library that goes through, looks at your DB sets and creates all the CRUD for you, your create, read, update, and delete endpoints on your behalf. So maybe you want to do that. But there's a whole load of nice features around minimal APIs, and you can start to sort of collect them into your module and just have all of those in there. And then you can bring them all together in an extension of web application and add those there. And then via your reference, you can also do this with all of your services that you need to instantiate, because they all have to be available for your web API because we've got that single executable. And you can see how the complexity is coming in now. So we also have our dependency injection stuff. So we've created all of these extension methods within the module. And then in the executable, we can add those in. So there's our everything that we need to register for dependency injection, and then we have everything that we need for our endpoints. So your web API is, as the executable, is responsible for instantiating everything that your modules need. Now, when you come to break one of these off, you've already got the extension modules, so you can add a new extension methods, and you can add a new executable to your module. So let's say we were doing the order module. You could add an orders web API to that, and then you've already got the extension methods to register inside that one's program. So you don't have to do any different work. You just take these two extension methods out of your web API program and put them in your new executable program. Bless you all. So how do we do the intermodule communication? So if we have module A and module B, are we going to do this direct call? We've got some kind of public interface for them to chat to each other, possibly in that contracts folder or something like that. That seems kind of feasible, yeah? That's what you're going to end up with? Do we like the look of that? Who wants that as their architecture? Who's already got that, trying to move away from that? Okay, yeah. It does. So we have that. This isn't ideal. If you end up a bit of like that, if that's your pragmatic approach to it, that's okay. But we're trying to avoid stuff that looks like this, boxes with multiple lines going everywhere. This is not a fun place to be. So rather than direct calls between our modules, we might use the mediator pattern, for example. Okay, so we have our mediator. You could use mediator from Jimmy Bogart if you like, but again, that's complexity. A standard mediator is quite simple to implement. Okay, I say simple because everything's always difficult and it depends where you're coming from, but it's not excessive to implement, and it's good to understand how a mediator works. So what this does is each individual module can talk with the mediator, and then the mediator will pass that on to the other module. Okay, so they talk via this mediator, which is, we've decoupled the modules from each other, and we've just got this one sort of layer that's handling all of that communication, a bit like the web API. Okay, we can use messaging. So with that, we have a producer, they add a message to a message queue, and then we can dequeue it, and a consumer. So a similar approach, but again, now we've added complexity, but it may be necessary. So how this works is we have a module talk to the message broker and say, hey, I want you to pass this message on to kitchen, It doesn't quite work like that, but it's basically got a little envelope with the address. So anyone who's interested in this can have it. And then Kitchen could go say, yes, that's me. I'm interested in that, and grab that message, okay? So we've again kept that decoupling between our modules. So this is what that looks like. So all of our modules communicate via the message bus. Kind of looks like that, doesn't it? I mean, mediator, message bus, yeah? Very similar. So you can start with the mediator pattern, which is less moving parts than having a message broker. That hugely adds to the complexity, the message broker. But you can keep that decoupling by having this loosely coupled connection between your modules. And then when you want to start going into a partially distributed or a distributed system, you can then switch to your message bus much more easily than if you had all your modules talking directly with each other. Okay, so it's about the thoughtful process of thinking what you might need to do in the future against what you need to do now. So a system like this is often called event-driven or message-driven. You may have been to James's session this morning on event-driven architecture. If you didn't, you can catch up with it on the YouTube stuff, and he covered event-driven architecture. I believe that Ian Cooper covers that as well. There's quite a few people doing that. There's lots of talks on it. I suggest you go and watch them. It's really interesting. We'll loosely go into some of the aspects of it. So in our modular monolith, we do have some things to note, that the web API is our only executable. So if we are going through the message broker route, everything needs to be registered in the web API. So that you're like, but now we've got message broker in a modular monolith. Oh, what do we need that? Message brokers are highly scalable, okay? They're very resilient. So you're adding those things into your modular monolith only if you need it. And also when you start going for your satellite pattern and breaking those individual modules off, you don't have to think any further about the communication. It's already there, okay? So it's up to you whether you think, well, I'm gonna go straight for the message broker, or if you're gonna keep your complexity lower and go with the mediator pattern, okay? But just knowing that you can do it is important. We have some types of messaging. There's a lot of different communication patterns. That's a whole talk or a workshop in itself. But I want you to think about these two, because I'm going to show you an example in a minute. We've got thin messages, sometimes known as events. You're very similar. You've got like an ID and a status or something like that. Very, very small. All right, it reduces the traffic and it can be very performant because it's such a small, tiny bit of data. Sometimes you actually need to pass along big chunks of data to your modules because remember, we've got these highly cohesive sections. If you think about our order module, it owns everything to do with an order, so it has all the order data. But if we have the kitchen service, that kind of needs to know what's on the order, doesn't it, to cook it? So how does it get the order data? Well, one approach is to send it a fat message. I don't like the naming. I think there might be other names, but I haven't found them. But this is kind of a recognized name. So we've got a message that has the entire model in it, and then that's put onto the message broker. So that's quite a big chunk of data, and that can have more overhead. But, you know, that may be what you need to do. So if we look into our Taki-Taco system, and this is just one way of doing it, and this is a little bit contrived because you might not need to do this, but just to paste an example, we create an order, so we've now got an order ID, and then we go and say, I'd like a payment, okay? Now we want to send out an update saying the order has been paid. So then that's where we go and put out a message saying, or an event saying, orders update paid for this order. So if I show you down here, you can see we've got a tag, a name on the message. These are routing keys if you're using something like Rabbit. And this is saying, ID of this is now paid. And if we go over to our order module now, it's listening for any sort of order updates because it needs to go and update the order record to say what status that order is in. And so it's listening for that. Now we also have our kitchen module, and this is our queue, our topic exchange, because this is a RabbitMQ example, and we have our orders detail request. So that's our request for the FAT message. It's saying, I've got this order ID, but no details of what I need to cook. So, hey, can someone send me some order information? So it sends out this request, and then our order module is listening for that request, and it creates the message that has all the response. And then our kitchen is listening for that, okay? So there's a sort of possible system of communicating between your modules, all right? So we're saying, we're passing around these super lightweight events and going, yep, this is paid. Yep, this is processing. Yep, this is collected. And then we've got these other messages going around, okay, I need a little bit more information. Can you send that to me? Now, you may choose to do that differently. You may keep it super lightweight on your message broker, just sending these events around, and then the kitchen, maybe you set up an HTTP call to it or something like that. Maybe that's the approach you want to do, or you have that go and make the request via a mediator, because you can start to have these things in parallel. You've got to think of good reasons why you want to do that, but you may, well, that may be the pragmatic approach that you still have a mediator for the kitchen to talk to the order to get the order details, and you keep your message broker super lightweight. Okay, so you can sort of blend these all together and do what suits you best. Right. So we have drastically increased the complexity of the system. You need to know that. We've now got a message broker. We've got these strict rules that we have to adhere to. This is much more complex. We have to consider error handling, implementation details of message-based architecture. And now you need to go and do a workshop and another talk on like event-driven architecture and messaging and all of that, okay? That's the next one you need to do. But we have, thank you, our modules are now loosely coupled, and we're Distribu-ready because we can easily convert them into satellites, all right? So what's the lesser evil here? So that's where you need to keep that pragmatic approach. Preventing the inevitable, a big ball of mud. How do we stop it? That's not a place we want to be. And we always start with the best intentions when we architect these systems, and then we get sloppy, we get lazy, there's deadlines, we need this yesterday, and that starts to have an effect on your architecture. So enforcing architecture, you have code review, automated tests, compile time, style guides. These are just some of the ways that you can start to enforce your architecture. So let's go through those. Code review, I'd like to class pair programming in this. I think pair programming is a great way of ideation and approach and getting a second set of eyes on your work, but you shouldn't depend on pair programming. That's putting a lot of load on someone else to also know the architecture of the system. They need to know it. They need to be on the ball. Maybe they had binged on Netflix the night before till 4 a.m, and now they're a bit tired. Yeah, it looks great. Yeah, commit. Off you go. It can have a slow turnaround. You're waiting on that person to be available, to review your code and things like that. But I do like that you can challenge the status quo. We don't want to be in the situation where we are going to do it this way because that's the way we've always done it. And I think pair programming is a way to have open discussion in a small environment, like 2 or 3 people, where you can feel like it's safer to have these discussions, all right? And then you can bubble those up. Now, compile time, we do this through encapsulating, by having things private by default or internal. And I got in a bit of an argument last year, I think it was, where someone said, don't bother making anything private or internal because you can just use reflection. Okay. All right, so when I'm a developer and I'm using this other thing and I'd like some feedback whether I should be using this public thing, yes, I could go and break the rules and get it via reflection or the unsafe tag thingy that came in .NET 8, but at least I know I shouldn't be doing that, okay? So go and use the minimum required access for your application, for your code. I mean, a lot of the code editors default to private. Leave them defaulted to private until you need to open up that access. So if you remember this, our orders is completely internal or private. Order tests is exposed. We put a tag in the CS proj of orders saying, yeah, you know what, tests can view our internals, okay? You can put a tag like that, so you can have your test project looking at your internal code, and then the contracts is public because we want to allow stuff to share that. So we encapsulate that. As you can see, we've got our internal class, and our contracts are the way that our other modules know how to talk to each other. And that can look like this. So back to Tacky Tacos. We have our DTOs, data transfer objects, in our contracts. So we know what we're sending them and what we're decoding to. So we create a message, publish that to the broker. The kitchen module is going to pluck that off. And it's like, okay, because I have access to the other contracts of that module, I know what this is and I can use it. This is your bounded context. That's your interface between things, all right? So that's how we're starting to enable the communication language between our modules. So compile time, immediate feedback. The drawbacks, we need our code to conform to the architecture, so you all have to write it that way. As I said, it can be circumnavigated. It's undocumented. All right, so new people coming in, they're like, what do I do? What does this mean? We can have automated tests. We've got static code analysis tools and architecture tests. So if we look at the first one, automated, yay! Self-documenting often, they can do reports. They are often integrated into your IDE. You've already got them, it's great, use them. Now, they can also highlight vulnerabilities, any anti-patterns, and if you sort of set them up, you can put in your standards and best practices in that. You can configure them how you want, and then you can share that amongst your team so you're all on the same page. Architecture tests, automated, self-documenting as much as any type of testing is self-documenting. Fast feedback, you get a green tick or a red cross, and they have all of the benefits of like unit tests, but they're just for your architecture. They do take time and discipline to implement, and you do need to have good code coverage, but that goes for any tests. No point just having a few. You need to build that code coverage. So this is an example of an architecture test. So you can start to see, you go like, well, I've got stuff in this assembly, shouldn't have any dependencies on stuff in this namespace or this assembly. So you can start being very explicit. So if people start referencing something that they shouldn't, your test is going to fail. Like, no, you're not supposed to be able to access this or have this namespace in this namespace or whatever, okay? So you can start to go through them. I have a YouTube video that goes through 2 libraries and sort of does a whole demo. So if you're more interested in that, you can check out that video. And then we have a style guide. Now, this is documented. It's a great resource for everyone to go look at and remind yourself how you should be writing your code. This is the C# style guide at Google, and you can you could build on this. You can see it goes in file names, organization, loads of stuff. Go look at that. You can have a play and see, oh yeah, we can adopt that, we can use that, and carry on from there. Thank you. To summarize the modular monolith, I nearly got the words out. This is where modularity is important. So you want to be able to encapsulate things. You want to be able to go and distribute things at a later date. But the overhead and complexity, put that in there, of deploying microservices is not justified. I cannot stress this enough. If you do not need to go into a distributed architecture, do not go into a distributed architecture. Remember those CTOs on the golf course? Say no, or try to, at least. Argue.
Or may not lie.
So you just need to think, well, we may want to go this. You think, yes, we are expecting huge growth, so let's design our software to support that, to have minimal technical debt, that we can do this easily at a future date if and when we need to. Okay, so the key things to remember: be pragmatic, not dogmatic. I think I drummed that in enough, okay? That was like a favorite saying of it. Just be pragmatic and be aware of the technical debt, because every decision you make may have a sort of consequence down the line. It may be the most pragmatic approach now, but know that that may cause knock-on effects down the line. And that high cohesion, loose coupling. So those are the sort of things that you should take away to whatever architecture you're doing. Whatever you're doing, remember these things. They don't just apply to this. Think about these as you're writing your code, always. Now for the question you all want to ask, even if you didn't know you want to ask it. Can I use .NET Aspire in a modular monolith? Yes, you can. Not right now, because it doesn't support half the things, as I've learnt recently, and it's only in preview 2. But yes, you can. You can put your modular monolith in there, and then all of the things, if you're starting to have multiple services, you've got caching, your database engines, your message brokers, it can start them all up for you, okay? You probably have a few executables. You've got your web API, and then your like web clients, and maybe your satellites. Now you can bring them all in there and start to build them up there, okay? So yes, I do think it's quite well suited to that. So yeah, give it a go. That's my YouTube. You can go and find it, Layla codes it. And I say I've got an architecture video on there for architecture testing. And with that, here's one final weird AI-generated thing. It made me look like some demon that's going to come and, you know, like I said, hunt you down if there's a red thing over there. Thank you so much for coming and joining me. And I hope you have a great rest of your conference.